Section 3.4, it's marginal functions in economics. Marginal analysis is something that's studied in economics. It's a study of the rate of change of economic quantities. For example, an economist is not just concerned with the value of the gross domestic product, but he or she wants to know the rate at which it's growing or declining. So we'll be considering other quantities in this section, like cost and revenue and profit, and we won't just look at cost, but the rate at which the cost is changing. So this is total cost. Capital R of X is total revenue. A little review from chapter 2. Capital P of X is total revenue. Total profit. So this is the actual values or the total values, but when we talk about marginal cost, marginal revenue, marginal profit, what does that actually mean? We will be discussing that in this section. Before we move forward, I want to reiterate that this should be in uppercase, because a lowercase little p of x represents price, okay, per unit. So recall that revenue, capital R of X, is lowercase p of x times x, okay, price times quantity. Price per unit times the number of units. Also, if you know revenue and you know cost, then profit, capital P of X, is revenue, capital R of X, minus cost. Okay, we're going to use the worksheet here to discuss marginal cost, and then we'll come back to our notes and discuss some other topics in this section. So we'll start off with the very first question here, and it says here that a division of Ditton Industries manufactures the Futura model microwave oven. The daily cost in dollars of producing these microwave ovens is given by this function, where X stands for the number of units produced. What is the actual cost of manufacturing the 101st oven, the 201st oven, the 301st oven? So if you actually calculate C at 101, that tells you the total cost to manufacture 101 ovens, all ovens from the first oven all the way through the 101st one. But that is not what we want. We want to know the cost in just manufacturing the 101st oven. So in order to do that, we're going to actually find the C at 101 and C at 100, which is the total cost to manufacture 100 ovens. Then if you subtract the two, if you do C at 101 minus C at 100, that'll tell you just the cost for the 101st oven. Okay, cost of manufacturing 101st oven. Now we can make our work a lot easier by not calculating it one at a time, but using our graphing calculators, typing the function under y1, so it's 0.0002 x to the third power minus 0.06 x squared plus 120x plus 5,000. Okay, then you go to the table, and let's delete all the old values we had. 101, and you want to go over. If you just stay here, you won't see the entire value. Use your cursor so you can see all the decimal places. So we have, okay, 16714.0002. Then I'm going to type in 100, and this is just exactly 16600. So if you was to subtract this, what would you get? So it's 16714.0002 minus 16600, and you get 114.0002. Now the question also asks us the cost for 201st oven. So this is for the 101st oven. 101st oven. For the 201st oven, it would be C at 201 minus C at 200. You can calculate that as well. There's yet another way to use our calculators to make this go faster, and that is once you type in the function as y1, if you go to bars right here and y bars, function y1, okay, and type in parentheses 201 minus, go back and do the same thing again at 200. Okay, so this is C at 201 minus C at 200. Okay, and if you don't like all the button pushing and you want to do it the old-fashioned way, you can. Okay, so there it is. That's the cost to manufacture the 200 first oven. And for the 300 first oven, we need to calculate C at 301 minus C at 300. Again, on our calculator, if you go second, enter, just use the back arrow and change the 2 to 3. You don't have to type much. And I'm getting 138.1202. Alright, so back in our notes, to figure out the cost of each of these items, this is the kind of calculation we're doing. But marginal cost is something that's even closer. You want to know, exactly what's happening at each of these points, not just 1 over. So the definition of marginal cost is defined to be the derivative C prime at x. So this is kind of like saying you have C at x plus delta x. If you go 1 over minus C at x, all divided by delta x, the limit as delta x goes to 0. Okay, and we had used h in our class earlier, but it's the same idea. Okay, h as h goes to 0. So essentially we can do the derivative and find marginal cost. And similarly, if you are asked to calculate marginal profit, it's P, uppercase P prime at x. And finally, if you need to find marginal revenue, that would be R prime at x. Okay, so the title of the section was marginal functions, and these are the marginal functions. Basically, the word marginal, and you see the word marginal, it means take the derivative I'm going to show you why that works, because this is what you see in economics. This is something that's calculus, and how does that tie in with these answers? So to find marginal cost, we're going to go to C of x and take its derivative, C prime of x. We're going to use the power rule here. This 3 comes down and multiplies with the 0.002, so you get 0.0006 x to the second power, minus, when the 2 comes down, it becomes 0.12x. The derivative of 120x is just 120. The derivative of a constant is 0, so we don't write anything. So there is C prime at x. Okay, one more time. The 3 comes down, so it's 0.006 x squared, minus the 2 comes down, 0.12x, plus 120x's derivative is 120. Then we're going to plug in each one of these x values, C prime at 100, C prime at 200, and finally C prime at 300, and see what happens. Another calculator trick for me to show you here would be, if you're not going to type it in as y1, you can just go 0.006 parentheses 100 squared, because it's x squared, minus 0.12x, so that's times 100, plus 120, and you get 114. That's pretty close to the exact value. This is pretty close, and it's faster to calculate because the powers are lower. Now if I go second, enter, and change all the 100s to 200s, it tells me I get 120, which is very close. Again, they're just off by a little change. And then change the 200s to 300s, and you see we get 138. Again, very close to that value. Okay, so that's how you compute marginal cost using calculus. A lot faster than no calculus. No calculus, you had to do 2 bits of calculations, powers were higher. Okay, it's slower. Calculus with calculus. faster. Alright, so again, we will be seeing some other examples of marginal, and here's the second problem we're going to try. In this one, it says a company plans to produce X units of its product. The fixed costs of production are $300. The variable costs are $20 per unit produced. The relationship between the number of units sold, X, and the price per unit, lowercase p, right here, is given by the demand equation. Lowercase p, this is price. Determine the cost function, the revenue function, and the profit function. So the total cost is fixed cost plus the variable cost. And you can see here that the fixed cost is given to be 300, so that's going to be 300, plus variable cost is $20 per unit, so that'll be 20x. Okay, so we're done with that. Revenue is given by lowercase p, price, times quantity. So it's 50 minus 0.01x times x. X is the number of units sold. And we can multiply this out. It's 50x minus 0.01x squared. I just distributed the x through. Once you know revenue and cost, uppercase P, profit, is revenue minus the cost. So it's this 50x minus 0.01x squared minus, and make sure you either use parentheses or immediately distribute the negative sign, because there are two terms. So when you distribute the negative, you get negative 0.01x squared. 50x minus 20x is 30x minus the 300. That's the constant term. After you do this, part B asks you to find the marginal cost function. That's the first derivative. Take the derivative of C. The derivative of 300 is 0. 20x's derivative is just 20. And you're done. Marginal profit, R prime of x. The derivative of this, the power rule, 2 comes down, negative 0.02x. 30x's derivative is 30. That's a constant, and that's all you have to do. For the next question, we're going to go back to our lecture notes and discuss what this is talking about. The topic here is elasticity of demand. Okay, so elasticity of demand is something else that you see in economics, and I'm going to direct you to a certain page in your textbook for this. This is 3.4. We're looking at oops, hang on, my iPad is a little bright here. I'm going to try to dim that. I think that's a little better. Okay, so elasticity of demand, I think I should brighten it a bit. There we go. It's on page 206 in your textbook, and the discussion for elasticity of demand starts a little bit up here on the top of the page. And what it talks about is how some commodities, the way they're demanded, they decrease when the price increases, but sometimes the demand stays the same depending on what the item is, like gas and milk, things that people need. But there are some items like that are not really luxury items, you know, they are luxury items that you don't really need. So the price goes down and people stock up. So that's elasticity of demand. Now, the calculus definition, you can calculate the elasticity of demand by using this formula. It's E of P. E is elasticity. It's negative lowercase p, so it's the price, times F prime of P, where that's given to you as X, divided by F of P. So depending on what you get as your result, something's going to be either elastic or inelastic. And this is also described on the next page right here, page 207, that the demand is elastic if the E value you get is greater than 1, unitary if it's 1, inelastic if it's less than 1. And I would also encourage you to read this little paragraph on page 208 that says that if the demand is elastic, then a small increase in the unit price will cause the revenue to decrease because people aren't going to buy it. Okay, and if there's a decrease in the price and the revenue will increase and people want to go and buy if it's on sale. If the demand is inelastic, that means it's a necessary commodity like gas or milk or bread, then even if you increase the price, people are still going to buy it, so the revenue will go up. If the price goes down, revenue goes down because people just buy the same amount. And then unitary, if its E is 1, then if you increase the price a little bit or decrease it, the revenue stays about the same. Alright, so let's try this last question on the worksheet and see how we do. So it says compute the elasticity of demand for this. Now remember the formula, the elasticity E of P is negative P F prime of P divided by F of P, where X equals F of P. Okay, so that's the formula that we have from our book. So right here we need to solve for X. To get X by itself, I'm going to move the 20 over, and I'm going to move the 1/3 P over, so it's 20 minus 1/3 P. So this is F of P. In this formula I need the derivative, so let's calculate that. The derivative of 20 is 0, so I get negative 1/3. So E of P is negative P times F prime, which is negative 1/3, divided by F of P, which is 20 minus 1/3 P. I'm going to clean this up a little bit. When you multiply two negatives, you get a positive, and here's E of P. Okay, now you're also told that the price is 30, so let's plug in 30. E at 30 is 1/3 times 30 divided by 20 minus 1/3 times 30. If you clean this up, 3 goes into 30 10 times, 10, so you get 20 minus 10, which is 10, so we get E to be 1, which means that the demand, this implies the demand is unitary. Okay, so that's the conclusion for that problem. A couple things that are not on this worksheet that I want to discuss, which will show up in your homework, is average cost. Cost is C of X. Average cost is denoted by C bar of X. It's a notation you see in statistics, but you put a bar, it's average or mean, and it's given by total cost divided by X. So if you want to find the marginal average cost, that would be the average cost and its derivative, C bar prime of X. So give the homework a try, and as always, let me know if you have any questions.